Now in this lecture, we shall learn that if the span of the roof is greater than 15 meters, that is this D value, the one that we had considered in the earlier example as 12 meters, what if the span is higher, that is 15 meters? And that is usually the case when we are dealing with, very large stadiums. So in that case, how we can calculate that? So the code guides us that if the span is greater than 15 meters, and if the natural frequency in the first mode. Now, I presume that you do have basic understanding of the dynamics of the structures. And let me just, introduce that here that when I'm talking about the frequency, I'm talking about the frequency of this cantilever roofing arrangement. It may be truss, it may be a single I beam, or it may be a, we can say, space truss kind of structure. So the frequency of this particular structure, the condition is that it should have the frequency lesser than 1 hertz. So if the frequency of this cantilever roofing structure is lesser than 1 hertz, whatever is the value, according to that we can calculate the value of the C dyne. Dyn means the dynamic coefficient. So in simple words, we can say that when we are dealing with the span greater than 15 meter, we do need to understand that the dynamics of the structures needs to be considered. Now, when first of all, we can simply understand frequency that has to be lesser than 1 hertz, and that is usually the case when we are dealing with the large span structures. Second point is that how we can calculate the frequency of these kind of structures. Now, when we're talking about the dynamics in the buildings, we do have various formulae in the AS1170 supplement, which do guides us that how we can calculate, or we can do the analysis in the softwares also. By software, we can use the space gauss, we can use the ETABS, we can use the SAP 2000 as per the availability. I'm not sure about the Strand 7, but space gas and ETABS and SAP 2000 can do this eigen and Rayleigh analysis or Rayleigh analysis for these kind of structures. So the steps that we need to follow: span is greater than 15 meter, okay. Second step we need to do is that we need to calculate the frequency of the roofing structure. Frequency of the roofing structure, as per my experience, for these kind of huge cantilever, it is usually lesser than 1 hertz. So in this case, in this practical example, we have presumed that the frequency that is calculated is 0.85 hertz. Now, next concept that we do need to understand is that when we are dealing with the dynamics, we are dealing with some parameters also. By some parameters, we mean all of these parameters that you can see in this equation. V design theta, that is a we can say, we very well know that is the design wind speed, and that has been presumed as 50 meter per second for this particular example. Value of GV. GV is basically we can say a peak factor for upwind velocity fluctuation. Now, what exactly we mean by the GV, that is peak factor upwind for upwind velocity fluctuation. Peak factor is a parameter that accounts for the variation of wind speed over the time. Let me just give you the answer also. GV is given as a constant, that is 3.4 on page number 59 of ES1170 part 2. For all the cases, the value of GV is given as 3.4. Just to give you a brief introduction, if we are dealing with the Indian codes or American codes or European codes, the GV is different for different terrain categories. In AS1170, there are these various terrain categories, terrain category 1, 2, 2.5, 3, 4, etc. Similarly, for the other countries, the value of the GV is different for different terrain categories. But in AS1170 part 2, the value is given as 3.4. And it is the, now coming to the definition again, what exactly does it mean? It basically accounts for the variation of wind speed over the time. We very well know that wind speed shall not be constant on a particular structure for a duration. We do average it. Some countries use 3-second wind speed. Some countries, or in some formulas, If we're talking about, let us suppose, dynamic analysis as per the, for example, Indian codes, they do consider 1 hour wind speed instead of 3 second. But in Australian, we are basically talking about the 3 second gust or 3 second wind speed. There are formulae also to convert the 3 second wind speed to 1 hour wind speed. So I won't go into that detail. Coming back to the concept here, what exactly is meant by the upwind velocity fluctuation? It basically accounts for the variation of wind speed over the time. So wind speed can vary. To consider that, we do consider this upwind velocity fluctuation. What is the value? It is defined as the ratio of the maximum 3 second gust wind speed. I repeat, ratio of the maximum 3 second gust wind speed. AS1170 Australian code basically deals with the 3 second gust wind speed to the mean hourly wind speed. So this ratio here, this ratio is basically, we can say, the value of the peak factor for upwind velocity fluctuation. And we can say that the peak factor depends on the terrain category, the height above the ground, the direction of the wind, and higher peak factor indicates a more variable and gusty wind, which can affect the performance and, we can say, reliability of the structures. So I hope the concept is clear to you. Why or what exactly is the basic aspect of wind velocity fluctuation? It accounts for the variation of wind speed over the time. About the value, it is the ratio of 3 second wind speed to the 1 hour or mean hourly wind speed. And as a basic parameter, the more averaging of time, the more we consider the time, the lesser is the value. So that is why this value should always be greater than 1. That is 3 second gust wind speed to mean hourly wind speed. And like in other codes, if you're talking about the value, it is usually between 3 to 4. For some terrain category it is 3, for some terrain category it goes as high as 4 also. But as per AS1170, it simply recommends that we do need to consider the exact value of the 3.4. So that is more or less better for the engineers. After that, the terrain category. Terrain category you very well know. It depends upon the, we can say, the buildings or structures that are basically encountered. What exactly the density or how exactly is the surrounding of the structure. Height, let us suppose the Z that we are considering right now is 10 meters. After that, value of IH. IH means the turbulence intensity. What exactly is meant by the turbulence intensity? Now, as a you may have traveled in we can say aeroplanes, or you may have taken a flight to some place. Now you must have heard that whenever airplanes experienced vibration, the pilot do announce that there is this turbulence coming or there is this disturbance outside. So that is basically the wind turbulence that we are right now considering here also. What exactly is meant by the turbulence intensity in simple words? It is measure of the variability of the wind speed over time and space. That is, we know that wind speed do vary. It varies over time also. It varies over the space also. So it is an important parameter that do affects the dynamic response of structures. How it affects the dynamic response of structures? You can see that in the places where there are no external disturbances, or we can say that the ground is plain, there is no as such disturbance to the flow of the wind. In those places, turbulence intensity is less. Here you can see that 0.128. At the same time, when we are talking about terrain category 4, that is a place where there is this dense city. There are a lot of buildings surrounding to that building. In that particular area, you can see that turbulence intensity is high. Why? Because wind do experience major disturbances in its smooth flow. So as the wind get disturbed, we do say that it shall encounter turbulence. In simple words, if you are traveling in an aeroplane, there is this wind outside, you do experience turbulence because aeroplane do act as the disturbance to the smooth flow of the wind. Similarly, in building structures, if we're talking about the turbulence, so in that case, the more the number of buildings we can say surrounding the structure. Let us suppose there are these various buildings or various trees out in near to the building under the consideration. So the more the wind gets disturbed, the more shall be the turbulence intensity, that is IV. That is why for terrain category 4, IV is high. For terrain category 1, IV is low. Similarly, for same terrain categories, as we go higher, that is, let us suppose this is the building, and as the wind, flows higher, there are these, some disturbances to the flow of the wind. But as we go higher, there is a less probability that the wind shall get disturbed. So that is why for same terrain category, the value of the IV, that is turbulence intensity, is, we can say, higher for lesser height, and it is lower for higher, we can say, or for 100 meters above the ground. So for same terrain category 4, we can see that if the building height is 5 meter, the turbulence density is 3.342. And if we're talking about the turbulence density at 100 meter height, it is only 0.233, and it goes as less as 0.087 for terrain category 1 and height 200 meters. So basically, as we go higher, the wind experience less turbulence. Reason, we do encounter less structures and less disturbance to the smooth flow of the wind. So that is the we can say a basic analogy to understand the turbulence intensity. Now in this case, if we want to calculate the value of the turbulence intensity IZ, we can presume that suppose we are talking about a terrain category 2. So when we're talking about a terrain category 2, in our case height is 10 meters. So we can simply consider this value here, that is 0.183. Yeah. So after that, the value of IH, or we can say IV, or here as IZ. So any term can be used, but in the formula it is given as IH. So value of IH, that can be taken as 0.183. That is value of turbulence intensity at height H. So N1, as I said that in either of the software, Space or ETAP SAP 2000, any other software you can be used to calculate the first mode frequency of the vibration of the cantilever rope. In which mode? We are not talking about the shear mode, we are not talking about the axial mode, we are talking about the vertical bending mode. So but just to give you a brief idea, let us suppose this is the roof here. So in the vertical bending mode, we do need to check the first mode frequency. How we can calculate that? We can simply apply load here for the load which shall bend it in the vertical direction. So that shall help in calculating you the first mode frequency of the cantilever and vertical bending mode. And I always prefer Rayleigh analysis over the eigen analysis for these kind of we can say cantilever or critical structures. After that, D, if we're talking about the span of the cantilever, we can presume it as 16 meters. So the value, this is basically the condition that right now we are first checking. The condition is that this value, that is B design theta, divided by 1 plus GV into IH, multiplied with 1 divided by N1D. This value needs to be greater than 0.4. In our case, the value is coming out as 2.266. So that is obviously okay. After that, if we do need to calculate the value of the C dyne. So the value of dynamic coefficient C dyne can be calculated from this particular formula. In here, you can see that the basic equation is can be broken up into 1 plus. So the value of C dyne shall always be greater than 1. Second, the why we had considered this condition, it is because if this value, that is B design theta divided by 1 plus GV into IH multiplied with 1 divided by N1D is lesser than 0.4, then this basically is a negative number. So that is not required, because in that case C dyne shall be lesser than 1. So that is why always check that this value has to be greater than 0.4. And more or less, for we can say for these kind of structures, it is we can say greater than 0.4. So this value can be calculated. It needs to be multiplied to 0.5, and again then it needs to be added to 1. So in our case, this value is coming as 1.934 in this particular case. So as the frequency goes lower, that is we can say time period goes higher. Let us suppose the frequency we can reduce it to approximately zero point 0.6. So in that case, you can see that the value of seed ion is as high as 2.4. So that is a very high value. Or if we reduce it to 0.95 hertz, so in that case, the value of seed ion decreases to 1.81. Similarly, if we change the turbulence intensity also, let us suppose instead of terrain category 2, we are considering terrain category 4. So we can change it to from 0.183 to 0.342. So in that case, you can see that basically the value of seed ion is less, and that is expected also. Because if we are considering the wind is already getting disturbed, or we can say dissipated, in that case, the structure shall experience lesser, we can say, dynamic effect of wind. So we can undo this. After that, if value of we can say the value at least that is the span of the cantilever roof. Let us suppose we keep it as increase it to 20 meters. So in that case, you can see that the value of CDAN is decreasing because we are not adjusting the frequency of the structure. I hope you're getting my point, as all of these values are approximate values. So if the span is increasing, the frequency shall also decrease in that particular proportion. So I hope the concept is now clear to you, that how you can calculate the value of C dyne for these kind of cantilever roof structures. Turbulence intensity, that is a very basic term. In simple word, the more the wind air experience turbulence in the form of obstructions by buildings or by trees, the we can say higher shall be the turbulence intensity, and in proportion to that, lesser shall be the final calculated value of the C time. Similarly, if we're talking about the peak factor for upwind velocity fluctuation, that is a parameter that accounts for variation of wind speed over the time. And we very well know that the AS1170 talks about the 3-second gust wind speed for all kind of structures. So I hope the calculation is now clear to you. You can simply download this file